Hey everybody, my name is Motswana, but you know what? Never skip a practice day. If you don't, hey, you gon' fail, hey. Easy play, easy say. Now let's get started, man. So you have a question right here. You know that's how we have to start with our slogan so we can get that motivation, okay? Now let's get started. So we have a question right here. This question say, okay, let's say here a ball P. Oh, means they talk about this ball. So it has a mass of 0.16. Oh, so we have a mass P. So let's say this is mass P and P. What is mass P? Equal to 0.16. 0.16 what kilogram? Now they say moving to the east means moving to the east. This side is to the east. And this way is to the west. Okay? So, and then with the speed, oh, so we have an initial velocity because moving with a speed of 10. So initially means the velocity started with. So say velocity initial of P. What is velocity initial of P? Is 10 meter per second. And they say it collide head on. Oh, so it collides kind of head on with another ball Q. So ball Q is coming, P coming this way, and Q come this way. Boom, bomb each other. Okay, now we're gonna say so we have information for P for Q. What is Q? So we know the mass of Q also. We can say mass of Q equal to 0.2 kilogram. And then what did I say? But if you see the Q move to the west, so initial velocity UI of what of Q equal to 15. But look, since it moved to the west, so you're gonna put negative. Look, man, we did even grade one. Anything go to the west means negative. But if you go to the right, it's positive. So we're gonna say this is negative 15 meter per second square per second because that's a velocity what? Initial of what? Of ball Q. So this is before they collide. Now we wanna go what happened after they collide. So this line here say they didn't come and collide at this point. After they collide, we see ball P is start to go to the left. But ball Q, we're not sure. That's what I say here. Find the velocity of ball Q after collision. Means after they have collided. In this before. So this is what they say. Oh, so we have a final velocity of P. Oh, so then we can say final velocity, or you can say velocity final of what of P we have, but it goes to the left. Means negative what? 15 meter per second. So we have a ball of P move to the means after the collide. Here's when they collide, boom, and this move to the but we don't know velocity final of Q. We don't know. But look, now let's see here. Define the term what? Momentum. So momentum always look. Momentum equal to mass time changing velocity. That's the momentum. Okay, that's what. That's it. Momentum. And the actual definition of momentum is always say momentum equal to change. Okay, linear momentum is the product of mass and velocity. So linear momentum is the product of mass and velocity. So we're going to say linear momentum because they say here define all the term momentum. So you can say here linear momentum, linear momentum, the what? And linear momentum is the products, is what the product photo of mass and what in velocity. Oh, so we can simply say momentum equal to mass times velocity. You understand what I'm saying? That's how we get what the momentum is, a linear momentum. Don't forget the linear momentum. So we got the first one, okay? Now, let's go for the second one. So for the second one, they say here, calculate the velocity of what of ball Q after they collide. Like I say, if you don't practice, hey, you can fail, hey. Easy play, easy way. Now, so we're gonna say here, look, this is very easy. So we have it from the law of conservation of linear momentum. So we have a law or rule, we can call it law or rule. Momentum before collision equal to momentum after collision. So what is momentum? We say momentum is equal to mass times velocity. So we have to mass of velocity before the collision. So we can say sum of momentum because momentum will represent using this letter like a P. Momentum before IPI equal to momentum after P after F after, but this is initial. So this is a formula for law conservation of momentum. Momentum before collision equal to momentum after collision. Okay, so you can simply write here momentum before collision, momentum before collision equal to momentum after collision, equal to momentum after what? After collision. Okay, collision. Now it has to be only single S, not double S. Collision, only one S, but double L. Collision. Okay, now, so then what we do next? Next step is easy, man. Okay, so let me write well here because it was not visible. So we can say momentum before collision. Say momentum before collision equal to momentum after collision. That's what we say here, sum of momentum. This sign represents sum of all the momentum. Now let's go. So we say momentum will represent using the letter what? M, B. So now before collision we had, before collision we had two things. We had a mass of P with the initial P because it's initial. So we're going to say, okay, so for that case now we're going to say mass, okay, mass. So we're going to say here, excuse me, mass initial, mass of P. So let me give you general definition. General definition, they always say M1, no, come on now. So we say M, because mass of P times initial of P, velocity initial of P. Now we want to come and do the same for the second one because we want a sum of all the momentum before collision. So mass of Q over velocity initial of Q equal to momentum after collision. So after collision means you reverse what we did here. Say mass of P times velocity final of P. Okay, let's say velocity final P plus, or you can say velocity P final or final P. Two of the other is or good, is acceptable. Okay. Okay. I think it's good to say like this. Let me say like this. Let me say like this. Let me say like this. So we say velocity mass of P times velocity in P initial plus mass with plus because initial, sum of all the initial momentum, mass of Q times velocity of Q what? Initial equal. Oh, so this is sum of momentum before initial, means you take the mass of these times is velocity, also the mass of these times is velocity. That's what they say. Now velocity after collision, momentum, sum of momentum after collision, we're gonna say is easy. So we do the same thing, but I'll say mass of P means here now we deal after collision now. Okay, mass of P times velocity of P what? Final plus, now we go for Q, say mass of Q, velocity final of Q. See now we deal with the final because after collision, but here it was initial low. Velocity of Q initial, velocity of U initial, but here is final. Okay, because after they collide, they move with a different velocity. Okay, you see what I'm saying? But now we say sometime it happened before I continue. They say they collide here. Then after they collide, maybe they move one direction. After they collide, they decided to move one direction. Have you ever seen a car crash sometime? The car, they bump each other, collide one another, and they start to move together like, see, means the final velocity is going to be single for that case. Meaning, if that's happened, which is not now, we could have said mass of, let's say if it was like, they'll say mass of P, V plus mass of P final, mass of Q, P final. But they have the same because they're going to move with the same velocity. See, they're going to move the same velocity. So for that case, if it was that case, and then you could have said equal to mass of P plus mass of Q, and then you put bracket in a single velocity because this velocity in here, final was going to be the same. But for now, no, it's not that case because after they collide, they move with a different direction. So meaning, we're going to say now, we can plug it in. What is the mass of P? Mass of P equal to 0.16. What is the initial P? 10, but this positive because it moved to the right. See, because if moved to the left, negative. Excuse me, so I'm going to say 0.16. So it goes 0.16 mass of P, which is this, times initial velocity of P equal to 10 because positive moved to the right, so it's 10. With plus initial velocity of Q equal to 0.2 kilogram. And it must be in kilogram. If it's in gram, make sure you change to kilogram. Sometimes you're given in grams, so you have to change to kilogram. So you say 0.2, and then initial velocity 15 here. But look, 15. What is 15 moving initial? Initial Q was moving to the left. So to the left means negative because, like I said, the number line will lean in grade 1. Anything move to the left means it's negative. So negative 15. So 0.2 times negative what? 15. So we're going to get something here now. Let's go to the final velocity. So for final velocity, mass of P we have 0.6. 0.16 is 0.16, yes. Times velocity final of P, velocity final P we have equal to this one here, but it's negative because move to the left. So negative what? Negative because move to the left. Negative 0.5. 0.5. And then what we do with plus, okay, mass of Q. What is mass of Q? 0.2 times final velocity of Q. That's what we're looking for because look here, they say find the velocity of Q. So VQ, so I can just make a space here. VQ, see, V final Q, VQF. So we're looking for VQF. So we can just make a subject to the formula. So you can simply say, take a calculator now, and then we say plug in a calculator here, man. So I can start with this one first. See this one here? I can start with this. So I can say, okay, clean up my calculator here, quick. Clean, easy play. So we say bracket. Okay, 0.16 times 10 equal to 0.16, 0.16, 16 times 10. That's gonna give us what? Whatever you're gonna get. And then we plus by what? By 0.2. Then you multiply again by multiply by negative 15 because it was moving to the left, you see, by negative 15. Okay, so all this stuff here give us what? Negative 1.4. All this stuff on the left is going to give us what? Negative 1.4. So we can see the right negative 1.4 here. Underneath, negative 1.4. So all this negative what? Negative 1.4. Negative 1.4. Equal, now we want to come and plug that one right there. Okay, but remember this, you're going to get some and then you're going to bring it to the left. Okay, so I can simply say 0.16 times negative 0.5. Okay, times what? No, why? How did I get negative 0.5? This is not negative 0.5. This is just negative 5. Because you know why? Look, velocity final of what of P is negative 5. Okay, so negative 0.16 times negative, just like how we see there. Okay, let's plug it. So we're gonna say now 0.16, 0.16. Let's plug it. 0 times 16 times negative 5. Okay, this is going to give us negative 0.8. Negative 0.8. But look, so all this stuff here is going to go to the left because there's a plus. It's going to go to the left. So if that one negative 0.8 is going to become here plus. Equal, so here we're going to be left with what? 0.2 velocity of Q final. So how are we going to get velocity of Q final? Divided by 0.2 throughout. Divided by 0.2 throughout means divide by 0.2 divided by 0.2. This and this cancel. So our VQ final equal, so I can simply plug in the calculator. If you plug in the calculator, that's easy. So take a calculator here, okay? My apologies, family. Okay, so let's move the calculator this side now. And man, where am I going to put this calculator? Okay, let's put the calculator here. And then we say, okay, so we're going to say negative 1,5, negative of fraction. Let's put fraction here, put your fraction. This is negative 1, negative 1, 4 plus 0,8 plus 0, 0,8, 0,8, and they go to the denominator, 0,2, 0,2. And this is going to give us, okay, negative 3. So our final velocity of Q, see, put here a calculator. Okay, so we got this one. So we're going to say now, our final velocity of Q equal to negative 3, right, meter per second. So what that tells us, look, okay, let me just erase it and then I can explain to you because we don't need this anymore. Okay, just a second, let's make a space here so we can have a clean diagram. Okay, look, they say here velocity we got, not they say we have obtained velocity final of Q final, means this Q, since it's negative 3, means this Q is going to be moving in this direction. So we say our velocity final, our velocity of Q final equal to negative 3 meter per second. So meaning this moving to the left, the negative tells you, meaning this is moving to the left. So I can just say, if I could say velocity of Q final equal to 3 meter per second, and then I can say to the west. Then you don't write negative. If you say to the west, and then you remove this negative, because negative meaning to the west. But if it was positive, it's just going to be to the right. So it's going to be to the west, to the west. 3 per meter, what? To the west. That's so I don't have to write negative again because I wrote that to the west. Or I can simply write like that. See? So now we say, see, just a second, I'm going to drink my water. Excuse me. So we have a velocity now, pi of Q equal to negative 3 to the west. Okay, excuse me, sorry. Now, let's come here. Find the impulse of ball P during the collision. During the collision happened here. This way it's up here. This was before, and this is after. So they want to get impulse. What is impulse? Look here, man. From the Newton's second law of motion, from Newton's second law, they say impulse of ball P during the collision. Now, from the Newton's second law of motion, we say, okay, we say F net equal to mass times acceleration, okay? And then I want to show you how the impulse comes. And then we say, okay, then mass. But what is acceleration? Acceleration always equal to change in velocity over time. What does that mean? Meaning, change in velocity over time. Change in velocity, change in v, sorry, over change in t. But what is change in v meaning? Change in v, so we say net force. So this is Newton's second law of motion. Okay? So Newton's second law of motion. From the Newton's, you must write that when you want to practice, right? From the Newton second law of motion. Okay? So now we say now mass. But what is change in velocity? Change in velocity means velocity final minus velocity initial over change in time. Oh, so this is give us F net, right? Oh yes, give us F net from the Newton's second law of motion. So now I want to show you how you get impulse from this. So now we say, okay, we say now, look, we say now F net equal to change in momentum, because it's change in momentum. because mv, the change in momentum, because mass times velocity is the momentum. So it's like, say, change in momentum over change in time. Do you agree with me? Because this is this. And mass times velocity is changing momentum. We just did it now, like mass times velocity equal to linear momentum. Okay. So how do you represent mass times velocity? We say we represent using letter what? V. Letter P. Come on. Easy play. If you don't, hey, you gonna make mistake, you gonna fail, hey. Now we say this is same as say, okay, change in momentum is change in P. We did that over, because this is mass times velocity equal to momentum. So equal to over change in time equal to force net. I want to show you how the impulse come. So that's how impulse come. Now let's finalize. So take this change in T, multiply here. So finally impulse, how we get impulse? Look, F net times change in time. So you're going to say F net times change in time equal to change in momentum. And this is impulse now. This one is impulse. Let's do this. That's impulse. But that's how it comes about. But if you don't, you can just memorize this simple formula. See? Or if you forgot, you can start from the Newton's second law of motion. So our impulse equal to force times change in time equal to change in momentum. And the change in momentum we know is same mass velocity final minus velocity initial equal to, okay, net times change in time. So this is the momentum. See? And what is the unit of momentum? Unit of momentum is easy because look, unit of momentum. Okay, what is F? F is the force, means Newton, so unit is Newton. And what is time? Time is second, so Newton times second. That's a unit of momentum. You see? Or if you don't want to do that, you can just simply say, okay, I can use this. Unit of momentum also, it could be mass. Mass is kilogram. But what is velocity? Change in velocity is just a velocity. And the unit of velocity is meter per second. So you can say meter. So you can use any of these is acceptable for the unit of moment. Unit of the impulse. Unit of the impulse. I'm sorry, sometimes I can say things other way around, not in my intention. People say, but you say this. Why did you say this? You're confused. No, I'm sorry. You know, my intention was to say what? To say what? The impulse. See? So this is how you get your impulse. I'm sorry about that. Sometimes I might say things in twisting way, but I just pick what I mean to say. So the impulse unit is Newton times second, because it's force, net force times time, equal to kilogram mass velocity change in meter per second. Oh, so now we know the unit of impulse. Now we'll do the one now. Let's go to the actual question now, because this was not even the question. Easy play, man. So if you forgot, you can always derive, but also they give you, excuse me, at the back of the formula, which is this one. Let me show you. No, excuse me, sorry. What the formula? Okay, let's see, impulse. Okay, show you quick. Where is there? Now, sorry, it's not here, but I think you understand what I mean. But you can check in your formula sheet and you can always get there. Okay, now let's go back to the question here. So if you come back to the question, if you come back here to the question, they say what? Find the impulse of ball P. So ball P are during the collision. Oh, impulse we know. So we say impulse equal to F net equal to times time times change in time equal to changing in what? In momentum. Okay, so then we have a lot of information. So if I have a net force, then I was going to use net force. If I had a time, I was going to use a time, but I don't have none of this, so I can rather use the second one. So it so depends which data you have. So for this case, I'll say equal, but this one I have because they say of P. So momentum of P mass times velocity final minus velocity initial. And I have all the information. Mass of P, because they say momentum of B during the collision. Mass of P I have. What is the mass collision? Mass of P. Mass of P equal to 0.16. times velocity final of P. Velocity final of P we have is what is 5, but remember it goes to the left. So -5 meaning because it goes to the left. And then we minus. What is the velocity initial of P? Why we say P? Because they say impulse of P. Okay? Velocity initial of P equal to 10. So finally, we say you plug this in the calculator. Plug in the calculator. Take the calculator here quick. And then let's plug this. It's easy, man. So come here and erase everything here. Say just 0. And then we say, for that case, now we say, okay, 0.16. Sorry about that. Just have to pull it a little bit, okay? 0.16. My apology, right? 0.16. Bracket. -5. Minus 10. Okay, so -2.4. Okay, cool. So we have to move this one to the left. So we say then -2. I forgot. What is this? -2.4. -2.4. So the impulse we have -2.4. So what impulse we have? So -2.4. So what impulse here equal to -2.4. But unity can be anything. Oh, let's write like this. So what impulse equal to -2.4. So units can be any of the two. Either could be net force times time, which is Newton what? Newton per second, Newton times second, or I would just say -2.4. And then what? Mass is kilogram meter per second. So now and then that's going to be your impulse, the final answer. But look, fam, if you first time here in the program, right, make sure you come subscribe because it's very, very important you have to subscribe so we can continue this movement. And this question comes straight from a student from KwaZulu-Natal. Student of KwaZulu-Natal, man, they're very inspiring. They constantly ask me questions from Josini, from Durban Natal, from Pietermaritzburg, Johannesburg, Gauteng, and Soshanguve, all the way up there to Limpopo, Polokwane. Only Western Cape, most of the students, they don't send me a lot of questions. Come on, Western Cape, Cape Town. Come on. Bring some questions, man. So thanks a lot for your time. And you know what? You know how we do this, right? Because I want to inspire a lot of people so people come from, the same environments like how I was come from, how I was raised. They can be inspired when they see someone come from similar environment. They can also do it. So you know what? Never skip a practice day. Easy say, easy play. If you don't hate, you go fail here. Easy play. I'm out, man. So I'll see you very soon. Subscribe and share this with a lot of people. Peace and I'm out. I'll see you soon.